Hi, this is Arthur for November 9 update on the Tezos code base. So this week I'm going to give you a weekly update as usual, but I'm also going to give you a sense of where we're standing with respect to the overall completion of the ledger. This is something that was asked on Reddit to put a little bit this dev update in context. So I will do that in the second part. So first, the updates from last week. So on my own side, I've been working on documenting the proof of stake algorithm. Because right now, the documentation for it exists in two states: a very high-level description in the white paper, and a very detailed implementation. And we don't have an intermediary resource that would describe in more details what we think the proof of stake algorithm we have implemented is, that we can compare with the implementation. So I've been working on this, and the more I work on it, the more I think that the right way to present it is a wiki, because you have a lot of interrelated concepts in a system like this, and making them hyperlinks make it easier to understand. And regarding the proof of stake algorithm, one of the things that I've been working on is Ppss. Now, in general, every feature that's not in the white paper, that every cool feature, every nice idea that we have, I've tried to say, let's move that to V2. Because we have a self-amending ledger, we have a self-upgrading ledger. So in the interest of shipping a safe ledger as soon as possible, we don't want to add too many features. However, so PVSS is a feature that I've long considered to be something that we would want to push in V2. I now think it would be better to push it up in V1. One, because it adds a lot of security to the system, and two, because it's not a big addition. So PVSS stands for Public Verifiable Secret Sharing. It's a technique essentially where you can have a group of people generate randomness. And when you generate randomness in a group of people, one technique is to have everyone commit to a random number, and then you XOR all the random number together. Now, the difficulty with that is people could not reveal their number and try to control the entropy. Now, in Tezos, we avoid that in several ways, with the fact that it can be expensive to derive the seed, and also the fact that there's economic penalties to not revealing your seed. However, PVSS allows you to do something a little better. What it allows you to do is it allows you to make a commitment, but also provably show to a lot of people that you've shared that commitment in little pieces with other parties, and that a certain fraction of these parties can get together and reconstruct a secret. It's something that's being used in other blockchains. I think Definity is using it, or is going to use it. Cardano is using it. It's a nice technique for generating randomness on chain. So I'm implementing something. I have implemented something to that end. I'm following the Shoemaker 99 paper. So nothing fancy, no pairing crypto. I'm just doing it with the Bitcoin curve. We're trying to make very conservative cryptographic choices here, since it's a crypto library, but it's a high-level library. I'm not implementing the curve operation. I'm not implementing the storage of the private key in the memory. And I'm just following the protocol. However, we'll still have to have it reviewed, obviously. So that's pretty much done, but it's not integrated into the ledger. It's just a standalone library for now. Other changes, we have autocomplete in the command line interface. So now you should be able to find new commands. It should make it a little easier to interface with the AlphaNet if you're using it from the command line client. Also, you'll see Michelin. So last week I mentioned how Benjamin has been working on refactoring the code around Michelson to make it easier to extract modules, to extract libraries. So now Michelin is this AST representation of Michelson, and that's been abstracted away from the protocol, so you can just use it as a library directly. And speaking of Michelsons, we now have annotations. It means you can track, instead of just tracking the type of expressions through the typer, you can give a name to them. So you could give a name to the variables in your storage. I say variables, but they're really constants. But you could give a name to the values in your storage and have the typer track it. So it's available in the Emacs mode. Try it out. It should make it a lot easier to write Michelson code. Lots of small commits, and by the way, so the order on GitHub is wacky. We commit from our internal GitLab to GitHub. So if you're looking at GitHub commits, the dates are a little weird, as you'll see. So for example, we had a bunch of update in November, which are showing in September. But if you actually look at the commits, you can see the real date. So we'll open up the GitLab. We need to clean it up some more, but it'll be easier to track the progress. So lots of work on a lot of different small things. So some renaming in the validator, work in the mempool, which is storing all the operations, more error reporting, better validation, work on the distributed DB, which is the distributed DB is not necessarily a good name, but it's the internal. It's not really distributed. It's the internal database where you store your blocks, where you store your operations. So lots of little, I wouldn't say bug fixes, but improvements here. And that's part of the general works that I've been calling the multi-pass validator. It sounds like one thing, but it really is this really big merge that's been going on for months, where we progressively replacing part of the network. Now, interestingly, a lot of the bugs that we have in the AlphaNet that sometimes stop the AlphaNets, they're a little bit frustrating because we want to investigate them. We want to have a live AlphaNet. However, we know that they're caused by old code that hasn't been replaced yet by the multi-pass validator. So hopefully we can merge that code before we spend too much time fixing all the bugs in the old code. Documentation. So like I mentioned that I was working on the proof of stake documentation. We also have now we can generate in the build system HTML doc, which should make it a little easier for people to learn about the code structure. We had a PR from Alex Coventry, who did a lot of work on documenting our data encoding module. I don't think it's made it to GitHub yet, but Milo has also documented the error monad, which is a big part of what we use in the protocol. So more documentation, and you're going to see a lot more of that. Some cleanup in our peer-to-peer layer. We also got there was legacy code and some dead code. So that's gone. And there's a little Easter egg in the clients for vanity keys. Not super useful, but something amusing if you want to generate vanity Tezos keys. Okay, so that's mostly it for the update for this week. Now I'm going to talk a little bit about this blog post. And the blog post is from May, but essentially from May to July, most of the work was focused on the software system that the foundation used for the fundraiser. So when work resumed around the end of July, August, we started again plugging this thing. So here's a few things that I mentioned in the blog post. So additional fuzz testing. So we did have a lot of fuzz testing in early 2017. We haven't done more fuzz testing. It's not a big step to put it back. But the thing is like we're changing. We're not changing our network layer so much, but we are changing our validator. And so I think I want to have the new validator in place before we do more fuzz testing. We haven't seem to have had any issues on this side. Bigger testnet, so that we definitely have. We have over 60 nodes. They're around the world. They're on different continents, and we definitely have a very messy testnet. So this has been going on great. We have a small regression on the size of messages. So we used to have very low-level peer-to-peer control on the size of messages that we would accept, and it caused problem because sometimes we want to have a bigger message. So we moved it up a few layers in the protocol. However, we moved it up too much. So like right now, it will download this giant block and then ask the protocol, hey, is this size okay? So obviously, the protocol might say, oh no, but you've already downloaded it. So we want to put some control back down a little bit. Another missing piece is the IP blacklist. So we have all the ways of tracking how bad your peers are and scoring them, but we don't actually do anything about it. And so we have a piece of code that does the IP blacklisting, but it needs to be reread, it needs to be debugged and integrated. So we don't know exactly how long this part is going to take. It's not a big piece of code, but we need to put someone on it because we're mostly looking right now at the multi-pass validator, which is not really so low level and Mikkelsen. Irmin scaling was the second part. So we have a great person for working on this who's going to be should be starting, I think, in a few weeks. I think it's going to take a good month to look through these issues. We had mentioned putting blocks on level DB, so that was done. We have the blocks on the and it did solve a bunch of problems. The problem is we have pretty naive bindings to level DB with LWT, and so we're losing a couple of things. One is we're losing concurrency, and also we're losing atomicity. We've had curved bases before because of that. So what should be done? Either we need to rewrite the binding to a level DB, make a better level DB binding, make level DB a backend for Irmin possibly, or there's some B-tree libraries in OCaml, and so just like write on one big file. That's not been decided, so that's something that still needs to be work on, but at least we averted the main problem. And also note that this is not a protocol level question. This is a node level question. So we can launch a protocol and then optimize the node after, because it's not consensus critical code. So that's important to distinguish. Multi-pass validator. So we didn't have a chance to test it yet because it's still a long merge process. Some stuff has already been merged. So the distributed DB, we used to be very naive about the way we would store blocks and operations. So that part has changed. We now have, and again, I call it distributed DB. It's nothing like a DHT. It's just the name is weird. It's just a database on your computer where you store the different operations, but you're pretty smart about where it comes from. So we have some traceability, which period it came from, why did we download it, and so on and so forth. Now the operations, we used to have this big index of operations. Now they're tied to blocks, they're tied to mempools. We had a pretty naive model early on where there was no concept of block headers. It was just this idea of a block that was valid or not. And so now we have much more efficient block headers with Merkle trees for the list of operations. That was a big refactoring. That was part of that was a big merge, which was part of the multi-pass validator. So that's also in place. In terms of what's left to be done, so I think one part is the pipeline validator. So I think that will be probably in place by the end of November. And that means just having an efficient validator. And this is really what's been blocking the AlphaNet, is that we have this really old validating code that's still buggy. And once we replace it with a pipeline validator, we should avoid a lot of these issues. And then the trickier part will be putting in place the multi-stage validator. But that's going to be a process over the next few months. Denunciations, we haven't made a lot of progress on this. We have a pretty clear idea of how to do it. It's not a big piece of code, but it definitely needs to be put in. I noticed bugs with the baking client at the time that was getting stuck, so that's being fixed. Although the baking client still needs a little more optimization. Separate the cryptographic signing process. One person's working on it right now. I don't think that should take too long. I mentioned a remote control for spending from the baker. That's not something that's launch critical. So if someone wants to work on that, that's fantastic. But it's not something we need right away. SSH will do for that purpose. Not too much work on the attacker yet. We run it once in a while on the network to see if it holds, but we haven't added more attacks. Gas monitoring, we have some unmatched code. Milo has been working on that. I also mentioned at the time that we had a decision to make on whether or not to do gas refunds. I think for launch, we're going to err towards not making refunds. So we'll have a fee model, which is a lot more like the Bitcoin fee model than the Ethereum fee model, where you essentially have to decide for yourself how much you're going to pay the miner for your gas limit. So you have to be... You're not just going to be able to put a very high gas limit and say, whatever, I'm willing to pay all of this, and you'll have to have a sense of like how much gas you really want to spend. Data storage. So again, we had a big decision to make. Do we want to do hash consing, or do you want to do something simpler? So the benefits of hash consing are huge. It means that, for example, every piece of code that's stored in a contract would only be stored once. So for instance, if instead of having library contracts, that you have to call externally to get a call, you could just copy their code and it would not take any more space on the blockchain. That's particularly helpful because it reduces statefulness. Part of the issue with the recent parity wallet problem was the statefulness, was the fact that they were depending on a library contract. If you do hash consing, you don't need to do any of that. However, we're not going to have hash consing in the first version. We want to ship sooner. So what we're going to do is probably you'll have to pay gas for deserialization of your storage, except for sets and maps, which will have a specific implementation. Because if we look at realistic use cases of smart contracts, really the only big data structures that anyone is storing right now is a map. At least that's what people are doing in the ERC20 token. You have a huge map of balances, and that is the main use of large storage. So we'll have an optimization for map, but not for the rest. Economic constants, that's also something I'm working on as part of my documentation of the proof of stake algorithm. So that should be probably coming out in about a week and a half, 2 weeks. From the proof of stake standpoint, like I mentioned earlier, we're adding PVSS. I think I used to think of it as a V2 feature. I think it makes sense to have it as a V1 feature. We're not doing it optimally. There's some really cool technique with cryptography, with pairing cryptography to do it. We're just using a very conservative approach for now. You're not buying a lot by having pairing crypto to do it. And yeah, another cool thing that I think I mentioned on Riot is the aggregation of roles at the delegate level. So that's another thing we're pushing. So instead of having this concept that you have a minimum amount of tokens to have to count as part of the stake, we take this amount of token, we put it at the delegate level, which means it doesn't matter if you only have a few tokens, as long as your delegate has one full role, then they can participate in the consensus algorithm. It's easier to track in terms of code. It has the same security properties, and it's a lot more fair. And it also means that we can have less roles than we would have to have otherwise. So it's also a lot more efficient. In terms of security audits, we haven't had the external audits yet. I want to have them, but I also want to merge in the code changes, because if we do an audit of the existing code base, especially the validator, which is a big part of it, and then have to change it, then we will have to redo the audit again. I would like to get started on this pretty soon, but it's not something that we have started yet. And testing, we have actually, I meant to look before this update. I haven't looked how much better we've done in terms of test. I know that there's a lot of Mikkelsen tests that have been added. Actually, let me just take a quick look. Let's see. So in source we have. Okay, so we have about 43,000 lines of code for Tezos, and in test we have about 48,000. So we were less than 10%. We're now above 10%. Yay! It's actually not that different. I was checking the Bitcoin repo today, and the Bitcoin repo stands around the same percentage. So I don't know. I do want to, this is not to, obviously the best test for Bitcoin is the fact that it's been live for the past 9 years. It's really hard to beat any of that, but I still do want to add more unit tests. Anyways, that's all for this week. I'll be back next week with more updates. Thank you.